Good evening. Here we are going to do a little video on solving a right triangle. All right, so here we go. Some things to consider when we're solving for right triangles are the trig functions. So if we go back, we can look and see that you've got SOHCAHTOA, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and TOA is opposite over adjacent. So have them here for you. Sine of theta is equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. And TOA, or tangent, I should say, is opposite over adjacent. All right, so check it out. Those are if we want side lengths, right? We have the angle, it's embedded in the sine, embedded cosine, and we want a side length. Now, if we are looking for an angle, now we're going to use the inverse. So sine inverse of the opposite over the hypotenuse, cosine inverse of adjacent over hypotenuse will give you an angle. And tangent inverse of opposite over adjacent will give you an angle. So if you want an angle, use the inverse button. It's on your calculator. It's got the little -1 sign little next to it. Okay, example number 1. Here we go. Solve the right triangle. Well, they gave us triangle A, B, and C with angle measure B of 27 degrees and angle or side length of 7. Little side A is 7, and we don't know this angle theta here. So what we've done is we've labeled the things that we need. We need angle A. Well, we know B is 27, we know C is 90. So what we can do is, because all angles on the interior of a triangle add up to 180 degrees, then that means that we must, yes, these two must add up to 90 degrees if that one's 90. So we take 90 minus 27 is 63 degrees, and so our angle theta is 63 degrees. All right, so now we need to figure out the side lengths. So here we go. We have A is side 7. B is the tangent of 63 degrees. So little b, where's little b? Little b is here. And so what we did is we found out that theta was 63 degrees. So we're going to use tangent and go opposite over adjacent. So tangent of 63 is 7 over b. And we know that these two have an inverse or an indirect relationship, so we can swap them. So B will end up being 7 divided by 63 degrees, or 3.567. Whoa, lights went out. All right, that's okay. Here we go. Cosine of 27 degrees is 7 over C. And we know that C then is 7 divided by cosine of 27. So little c is here, it's the hypotenuse. And we said the cosine of 27 degrees. Well, here's 27. Cosine is adjacent over the hypotenuse. And so we get is 7 over cosine of 27, or 7.856. Now, what we'll see here is that, do these answers make sense? Well, one leg is 7, another leg is 3, and the hypotenuse is 7.8. So if you recall your information about triangles, the hypotenuse should be the longest side. And in fact, it is, as side length C. All right, next example. Next example is right here. Put those lights back on. Let's scoot this over and let's look here. So here's triangle ABC once again, but guess what? They didn't give us any angle measures. Oh, no. But we have two side lengths. We have one leg that's 14 and another leg that's 10. So, first, we can solve for the two angle measures. One, by using tangent. A here, we've got opposite and adjacent. So, tan inverse of opposite over adjacent. We use tangent inverse of 14 over 10. And we get 54.5 degrees. Now we can find measure of angle B, because now we know that these two must add up to 90 degrees. So we take 90 minus 54.5 and we get 35.5 degrees. And I rounded to a half, just to keep it a little bit more interesting. C is obviously 90 degrees, and that's indicated by the square in the corner. Now, what we have over here are the side lengths. Well, we know A is 14 and B is 10, so we need C. We need the hypotenuse. So what do we have? Well, if we take A, measure of angle A, which was 54.5 degrees, we have opposite over hypotenuse, which is, opposite over hypotenuse is, yes, sine. You're right. Thank you. So sine of 54.5 degrees is equal to 14 over C. C is then 14 divided by sine of 54.5 degrees, which is 17.19. Again, we double check to make sure our answer makes sense. Is the hypotenuse the longest side? Well, C was 17, 14, and 10. Yes, each of those works out, and it seems to be in the right ratio or proportion. Okay? Anyway, that's solving right triangles. Hope you had a great time. Enjoy your evening. Thanks a lot. See you soon.